Hi everyone, so this is the last lesson for the week, our statistics lesson, and after a chat I've just been having with 13b, I've decided to revisit a question which I did go through in our clinic a little bit a week or so ago with the other group, with 13c, but I was not very happy with the way that I explained it. So I'm going to have another crack at it now. So it's question 3 from the Maths Genie stuff that I asked you to do on Venn diagram probability. So let's have a look at that. Right, so here's the beginning of our question. These first two parts, which didn't cause the problem, C and D did, but before we do, let's build up a Venn diagram that we can sort of chop and change around a bit. Now, you wouldn't be able to rub things out in an exam, but you've got lots of paper, so you could just draw more than one Venn diagram as you get to know more stuff. So let's start off with our universal set, and we know we're going to have our A and our B. And what it's saying when it asks for the probability of not A intersecting not B, it's all of the not A's, but it also has to be not B, which is just this zone here. And when it says probability of A or B equals 0.7, that means that, and that are all adding up to 0.7. Now there are only 4 different possibilities possible, and they've all got to add up to 1. So all you need to do for this is take the 0.7 away from 1, and that gives you 0.3, which is the first probability which we can write for certain inside there. Now the other thing we know is that A is 0.3, but that means including that bit there. So we want to know the probability it's not in A intersecting with the probability it's in B. So it's in B at the same time as not being in A. Well, that's this bit left over. Now we know that these other two bits that I've crossed out and replaced with 0.3, they add up to make 0.3. We've only got one zone not there. So this is going to be 1 take away the two 0.3s added together, which is 0.6. Take that away from 1, gives you 0.4. So far so good. Now let's have a look at the next thing it's going to ask us. Right, so now I've used a different colour here for the word independent, because we're told that A and B, so there should be a D in there for and, shouldn't there? A and B are independent of each other. Find the probability of B and also the probability that it's not in A or it's not in B, which means everything apart from that bit in there, because it's not in B is all of that, and you also add in that bit there. Right, but don't worry about that. Basically what we have to do is we need to sort out all the other bits of it from this. Now the key to this is that because it said it's independent, what we can say is I'm going to take this out for now, we know that that bit there is 0.3, don't we? We know that they add up to 0.3. I'm going to call this bit here y and this bit here x for now. What we know is to find the probability of B, if you look in your formula booklet, it'll tell you this. The probability of A intersection B, if events are independent, is the probability of A multiplied by the probability of B. So what do we know? We know that we're calling probability A intersection B y, and we've also worked out that the probability of x, we've worked that out already, haven't we? We've worked out that that's 0.4, so I don't know why I put x there. I should have put 0.4, because we know that's going to be easier, because we know the probability of A is 0.3, and the probability of B is going to be 0.4 plus y. Now we've only got one unknown in this equation, so all you can do, you can just pause the video and have a go at solving this. So y is going to be 0.3 times 0.4 is 0.12 plus 0.3y. Take 0.3 away, I get 0.4y equals 0.12. So y must be 0.12 over 0.4. And that's not right, is it? That should be 0.7y. You take 0.3y away from 1 over 0.7. Sorry. So if you put that into calculator and you go for and simplify it, or simplify it any way you like, it actually comes out as 6/35. So we can say that this bit here is 6/35. You could do it as a decimal, but it's horrible. Therefore, I'm going to change now from decimals to fractions. 4/10 is 2/5, isn't it? And 3/10 is 3/10 there. Now I know that the probability of B is going to be 6/35 plus 2/5, which is going to be 6/35 plus 14/35, which is 20/35, and that simplifies down to 4/7. So 4/7 is our answer to the probability of B. And in order to work this out, the probability of not A or not B, that means everything apart from 6/35, we can either work out what that is, or by doing 0.3, because that's the probability of all A, take 6/35, or we could just say it's going to be the same as 1 take 6/35, which is 29/35. And I can't leave like that. I'm going to have to put 9/70 there. But anyway, so that sorts all of that. And now I hope that's made more sense of that problem for people. If not, pause it, go back and watch it again, or ask me. But it's all about keeping things simple and making yourself a little equation. Generally, these probability things, there's simple maths but sophisticated thinking. Right, today we're looking at interpolation and standard deviation. So interpolation is how we find a position in a group for an important bit of data, be that the median, or in this case we want the interquartile range, so we want the lower quartile and the upper quartile and find the difference. And standard deviation being the measurement to say how much our data is varied, so how consistent it is. Right, so pause the video and see if you can remember what to do. You need to find the interquartile range, so you need to find an estimate for the upper quartile and one for the lower quartile, and take one from the other. So the upper quartile take the lower quartile is what we want. So for the upper quartile, first of all, if you add up all your frequencies, you get 80 runners all together. So we want the upper quartile at 3/4 of that, so that'll be the 60th runner. So the 60th runner, if we add these up, you've got 5 there, 5 plus 10 makes 15 to there, plus 36 makes 51 to there, 71 to there, and then you've got your 80 by the time you've finished. So the 60th runner for 3/4 of the way through is going to be 9 into this group, because your 51st is the last one in that group. So we are talking 9 out of the 20. So I'm going to write down 9/20ths. And then how wide is this group? Well, this group goes from 50 to 59. That seems like a width of 9, but you've got to be careful because it's time and it's been rounded. What about 49.5? That's going to go there, and 59.5 is going to go there. So it's not actually 50 to 59, but 49.5 to 59.5. So that is a width of 10. And then you're going to need to add it to the smallest value or the shortest time that would be there. So that would be 49.5. And then we are going to be taking away the lower quartile. Well, the lower quartile is the 20th value. So the 20th value is going to be 5 inside this group. So 5 out of 36 times the group width of 10. This time the smallest it could be would be 39.5. So we want 5/36 of 10 more than 39.5. Pop that all into your calculator and we should get exactly 13, and your unit is minutes. So between your whole middle half of your runners are going to fall within 13 minutes of time, whereas your fastest and your slowest, well, they've got a massive amount, haven't they? Could be as much as what, from 20 up to 69 up to 49, well, and plus a half, 50 minutes between the slowest and the fastest. Right, so that's the first part. Then the second part, using the midpoint, they've worked out a load of stuff for you, so they want you to use that. Now you may be thinking, can't remember what's going on there. That's when you need to look into your statistical tables and look to see that it gives you two ways of working out the standard deviation. This special notation here, or this one here. But either way, the variance is the standard deviation squared. So the variance is what's inside here before you've done the square root. So the first thing I'm going to do is just write down that variance equals, and then which one of these is going to be the most like this? Well, I can see f of x squared there, so I'm going to write down this one and then plug in my values. So pause the video and have a go at doing that, and then I'll show you what I've got. So this is what I've got. So I started off by copying down what the formula bit was, and then I said, right, so 183,040, n stands for the total of the frequency, and then to work out the mean you would need to add up all your total times and divide it by how many there are. So there's your added up total times divided by how many there are, and they want you to square it. So remember, the x bar means the mean. Put that all into your calculator, you should get a fraction like that, rounded to 3 significant figures, is 102. Now, to find the standard deviation, all you need to do is do your 1634 over 16, square root that, and that should give you 10.1 minutes to 3 significant figures. Right, so we're going to have one more that I go through, and then you'll be on your own with some Mass Genie stuff of the attachment that you should find there. Right, so this time pause the video and see if you can do this. Now, if you're not too sure, use your calculator. It is time to go to statistics mode, so hit number 2, and that should get our lists up. Now if you've got a load of numbers in there, you probably have, you want to delete those first of all. Then if you press calc and hit 1 var, oh, that's not what I meant. What I meant was hit set. We can check what your 1 variance is, and that is that list 1 will be a list of numbers, and the list 2 will be that frequency of those. You don't need to worry about the others. So now it's saying estimates because we've got continuous data that is being grouped. So between 11 and 13, this time we don't have to worry about 0.5s because we're going to exact amounts. So each one is 2 wide. So the midpoint is 12, the midpoint is 14, the midpoint is 16. Then track across and put in the frequencies 12, 14 and 4. And now the computer makes this laughably easy. If you hit 1 var now, x bar means the mean. So the mean is 13.46 recurring, or 13.5. 13.5. Make sure you put in degrees Celsius to 3 significant figures, and the standard deviation, this is the sum of all of them and all that stuff, but the standard deviation is that symbol there. So the x just means the standard deviation of the x's is 1.36 to 3 significant figures. So standard deviation was 1.36, and that's still degrees Celsius that we're talking about there, to 3 significant figures. So that is a pretty easy 3 marks as long as you remember where to go in your calculator. Now pause and have a go at using the interpolation to find an estimate for the 10 to 90% interpercentile range. First thing to do is consider your total frequency, which is 30. So you're talking about going from the third value up to the 27th, because 10% of 30 is 3. And you should have something that looks like this. I've put it all in one go in the calculator. So where did this all come from, just in case you're not sure? Well, the 90th percentile is going to be the 27th out of 30. So that means 3 less than the top. So it's going to be 1 into this group of 4. So it's 1 out of 4 times the group width is 2, and it's going to be more, it's going to be that much more than the lower limit of that group. And then we're going to be taking away the 10th percentile. 10% is 3, so it's going to be the third one out of those 12. So 3/12 times the group width is 2, added to the smallest possible value being 11, and that gives you 4, and that's still 4 degrees Celsius. So what it's saying is the middle 80% of the days, so 4 days out of every 5, it should be lying within a 4 degree variance, whereas it lies between 6 over the whole of the month. Right, now have a look at part C, estimating the number of days where the daily mean temperature in Kanban is more than 1 standard deviation greater than the mean. Pause the video and give that a go. Right, so this is about the number of days where the daily temperature is more than 1 standard deviation greater than the mean. So the mean is 13.5, and if you were to add the standard deviation on, you would get a temperature of 14.86 degrees. So we are talking about the number of days when it is going to be hotter than that. So it's going to be those 4 plus a little bit of this. So to work out how much of this that it is, so it's going to be 4, and we're going to be adding to that. Let's put this all in a bracket to keep it a bit simpler. If you take 14.86 away from that, you're going to get a very small amount of that group, aren't you? It's going to be way less than 1, and it's that fraction of the 2 degrees that we've got in there. And we're going to be multiplying that fraction by the number of days we've got. And if you pop that all into your calculator and press equals, you get 4.98. So that means we're going to estimate that to be 5 days. And that's that. You might want to spend a little bit of time thinking about the large data set and looking back at your notes on that, because you might be asked stuff about what it means to clean the data and things like that, which is talking about the fact that when you've got a large data set, you're going to have things which are mistakes in there, and getting rid of those as well. And then all I'd like you to do next is have a go at the Mass Genie work that's there. There's one question that includes coding. You don't worry too much about that if you can't remember what's going on with that. If you can do everything else on there, then that's marvelous.